All right, guys, the very last thing we need to talk about with trigonometry for this unit is going to be what's called angles of elevation and depression. First of all, we need to talk about your line of sight. Okay, your line of sight is going to be the pathway or the line that connects the subject to what they're looking at. This is going to be a horizontal line. Okay, your angle of depression is going to be the angle that goes downward from that line. Okay, and your angle of elevation is going to go upward. Okay, think about elevation, elevator. I know they go both directions, but when you're talking about elevation, you're talking about the height, how high up, so you're going to go up. If you think about the word depression, it means down, okay, like when somebody's feeling a little depressed or feeling a little down, so you're going to be going from that horizontal line downward. So over here, we can see here that your angle of elevation is going to be right here, and we notice that it's going to go from the horizontal line upward, okay, from the horizontal, it always starts the horizontal line and it goes up. There's your angle of elevation. Your angle of depression right here is going to go from the horizontal line and it's going to go downward. What also ends up happening is, we haven't talked about this in a long time, but these horizontal lines are parallel. And we now have segment TP right here is a transversal. Angle 1 and angle 2 end up being alternate interior angles. What this means, if we remember, they are congruent. So if I have an angle of depression, but I'm looking down here at something over here, I know that they're going to be exactly the same thing. Okay, and we're going to have a problem like that here in a moment. Okay, the first problem here is we have a space needle that casts a 67 meter shadow. The angle of elevation from the tip of the shadow to the top of the space needle is 70 degrees. How tall is the space needle? So let's go ahead and take a look at what this looks like. Okay, here's my space needle. Okay, I know it doesn't look like that, but whatever. We're saying here that it's going to cast a 67 meter shadow. Your shadow is always the horizontal distance. So this is going to be 67. We're saying the angle of elevation from the tip of the shadow right here up to, going up, first of all here, angle of elevation, we know we're going to go upward, up to the top of that space needle, angle of elevation, is 70 degrees. So there is our reference angle. We want to know how tall is the space needle and round to the nearest meter. So we're looking at the height right here. Okay? So let's take a look at what trig function we are going to be using. Remember that your space needle and the ground are going to be your 90-degree angle. So looking at our reference angle right here, okay, I'm noticing I'm not using my hypotenuse. When you do not use your hypotenuse, you are automatically going to be using tangent or TOA, opposite over adjacent. Okay? So here we need to decide. My pen, when I sit in that reference angle, it is pointing directly to the opposite side of the triangle. So it points to the opposite side, the OPP, or the O. We'll just label it O. We did in the last video. And then right here, right next to it, the leg that helps create the reference angle is going to be your adjacent, your A. So let's set up our equation. We have tangent of our reference angle 70 is equal to opposite x over adjacent 67. I notice that my missing leg is in the numerator. Numerator multiply. Okay, just like again, if you want to see that proportion, we just have 1 times x giving us x, and then we're going to multiply that 67 times the tangent of 70. 67, always remember to put that number first, times the tangent of 70. And if you're at home, use the Desmos scientific calculator. Okay, please stop, pause this on your own, and plug this into your calculator so you're practicing using the Desmos calculator as well. Thank you for pausing it and doing it. X is then going to come out approximately, to the nearest meter, 184 meters. The next problem. We have a pilot of a traffic helicopter sights an accident at an angle of depression of 18 degrees. The helicopter's altitude is 1,560 feet. What is the horizontal distance from the helicopter to the accident, round to the nearest foot? All right, so we have a helicopter. All right, there's a little helicopter. This is as good as my helicopter gets. All right. Now, the line of sight is going to be straight ahead. Okay, that's what we talked about up here, line of sight. It's going to connect to where they're looking at. It's going to be straight ahead. We need this so that we can get that angle of depression. Okay, the angle of depression, here's, let's say that this is the accident. Yeah, it looks like an accident, right? The angle of depression right here, rewind, that's not the line of sight, that's the horizontal distance we're going to need. The line of sight, he's going to go from, he's looking downward at this accident, sorry for the crooked line. The angle of depression right here, from straight ahead down to that site, is 18 degrees. We know that his altitude, so how high up in the air that he is 1,560 feet. We want to know the horizontal distance from where he's floating above to that accident. This is what we want. Here's our 90 degree. The problem here is that 18 degrees is not in the triangle. So this is where that alternate interior angles comes from that we're talking about here. Your angle of depression is the exact same as your angle of elevation. These will be congruent. So that means this will be 18 degrees. So now we can ignore all the stuff up here, and now we have our right triangle. Okay? So let's take a look at what we have here. I am noticing here that I am not using my hypotenuse, which means I'm automatically using tangent. A lot of times, angle of elevation and depression, a lot of times it's tangent, but not always. Okay? We'll see that here in a minute. So let's label our sides. From the reference angle, right here, the accident is 18 degrees. Across to the opposite side is our O for opposite, leaving that X is our adjacent. Let's set up that equation. We have tangent of our reference angle, 18, is equal to opposite, 1,560, over adjacent, X. The X is in the denominator, divide. So we're going to switch these two around and we're going to divide. So we'll have X is now equal to the 1,560 stays on top, and that tangent 18 is going to switch. And now we have this. Again, please pause it and practice it on your own calculator. A few things I did not highlight. I do apologize. We do want to make sure that we're seeing the angle of depression and we're rounding to the nearest foot. Okay? So here when we round to the nearest foot, it's going to be 4,801 feet. Pause it and get caught up. The next one, we have a flagpole is braced by a wire 8.7 meters long extending from the top of the pole to the ground. The pole is 7.4 meters tall. What is the angle of elevation to the top of the pole? All right. Yours should say round to the nearest degree. Right, should. Round to the nearest degree. So a couple things here we want to see. We've got our flagpole. Okay. We know that the pole is 7.4 meters tall. We have a wire that's braced extending from the top of the pole to the ground. That is going to be our diagonal. Okay, so here's our 8.7. All right, we're going to go ahead and connect this with the ground. Here's our 90-degree angle. Now we are asking, what is the angle of elevation? So we are going to be looking for this angle right here. Again, if you want to put an X there, that's perfectly fine. So let's take a look at what sides I have here. I do have my hypotenuse on this one. I told you it's not always with tangent, but a lot of them are. Okay. At my reference angle right here, I'm looking, my other side is on the opposite side of the triangle. So, I did that HYP again. Got H, it doesn't matter which one you do. And here's your O for opposite. In SOHCAHTOA, it is sine that we use for opposite and hypotenuse. So we have opposite and over hypotenuse. So we'll go ahead and fill this in. We're going to have sine of, again, either x or theta, whichever one you want to use. That's what we're missing, is equal to opposite, 7.4, over hypotenuse, 8.7. So this is where we change this around and we do the inverse. So we end up with beta equals the inverse sign of that fraction, 7.4 over 8.7. Please plug this into the calculator. Pause. Plug it into the calculator on your own. This, again, is in my opinion, the easiest one is finding the angle. Thank you for pausing it. And we're going to come up with approximately 58 degrees. Good job doing it on your own. All right, next one. We have a certain stretch of railroad, rises vertically 271 meters. Vertically is up and down. So here we have a vertical distance right here of 271. It covers, while it covers horizontal distance, so there's a horizontal distance, so bam, right here, creating that 90 degrees, of 865 meters. Assuming these tracks are straight, we want to know the angle of elevation for that track. So when we connect this, we're looking right here at angle of elevation. We're missing this, okay? So here, what is the angle of elevation? And again, I believe I changed it after I printed these up. It should say round to the nearest meter. So you shouldn't have to fill that in, but we do want to highlight, make sure we're rounding correctly. All right, so let's take a look at what we have here. I do not have my hypotenuse, so it's automatically going to be tangent. So tangent is opposite over adjacent. We take a look right here at this reference angle, okay, and opposite is going to be that 271. Adjacent right next to will be that 865. So let's set this up. We are missing the angle, so we have tangent of theta, or x, is equal to opposite, 271, over adjacent, 865. We're going to move that tangent to the other side by doing the inverse, so we will have tangent with the little -1 exponent, and our fraction 271 over 865. Go ahead and take a second and pause this. We are rounding to, sorry, I put nearest meter. Sorry, it should be nearest degree. Just never realized that. But again, yours should already say it. Hopefully I wrote it correctly on there. If it does say nearest meter, then I apologize. It's supposed to be nearest degree. So pause it. Put in that in the calculator for by yourself. Thank you. Now we're going to find out that, check to see if we got this correct. We should have come out to approximately 17 degrees. There's your angle of elevation and your angle of depression.